we have seen step voltage response to step voltage input response to series RC circuit, series RL circuit and series RLC circuit. What is step voltage input? Step voltage input means very simply, if this is T and this is V, then for T less than 0, the value of voltage is 0, and for T greater than 0 equal to 0, the response is 1. That is shown written as this, and this function is actually written as ut. Okay, so this is step voltage response. Similarly, we have step current response. Not response, that was step input voltage, and this is step input current. So for current, this is same, less than t it is 0 and greater than this it is 1. So what is the meaning of this? The meaning is, when we write like this, plus minus, let's say 2 ut volts, this means the voltage source is at t greater than 0, it is equal to 2 volts. Simple. Or in place of voltage source, if we have a current source, say IUT, this means it has a value equal to I amperes for t greater than 0. Okay, so this is step input current source, and that is step input voltage source. Okay, so we have seen step input voltage source. Now let's see step input step current source. So the figure will be like this. We have a current source, and we have, let's say, first of all, we have R and L circuit. Obviously, for current source, you have these things in parallel, not in series. So you can also say we are now analyzing parallel circuits, RLC. So I'm writing IUT so as to make it clear that this is a step input current source. That is, for t less than 0, the current is 0. So instead of a switch, we have used this function to understand that at t equal to 0, we have started, the current has started flowing. So we know for open circuit, when this is open circuited, we know our tau is, the time constant is L by R for RL circuit. Therefore, as we had analyzed in the series circuit, we'll have two, the whole current will be passing through the inductor, this IT. This will be equal to, one will be natural response, and the second will be the forced response. So what is natural response? It is AE to the power minus t by tau. We know this. And what is the forced response? That is the steady state, the value of the current passing through the inductor when we have steady state, that is t has gone to infinity. Then what? Then see, in a steady state, inductor behaves like a short circuit. I have told you. So when this behaves as a short circuit, no current will go into this. The current into the resistor will be 0. So all this current will go into inductor. So this IF will be equal to I. Clear? We have this equation. Now let's say at t equal to 0, our initial conditions. Let's say at t equal to 0, current is equal to 0. Let's say our initial condition is 0 for current, the initial condition for inductor. So if you put it here, this will become 0 is A, this will be 1, and this will be I. From here what you get? You get A is equal to minus I. So you put minus I here, minus I. So what do you get? Finally, the equation that you get is I 1 minus e to the power minus t by tau. Okay. So this is undoubtedly for t greater than 0. Okay. So our equation for current through the inductor when we have step input current source is this. Clear? Now let's see step current response for RC circuit. This is RL. Let's change it with a capacitor. This is our capacitor C. Okay. Let's say this voltage is V. Okay. So we know that when this is open circuit, we have the time constant tau equal to RC for RC circuit, and similar to what we did for current, our VT, the voltage across this capacitor, will have two components. One is the natural response and second is the forced response. What is the natural response? We know this is E t by tau. And what is the forced response? Forced response is the steady state value. At a steady state, what happens? The inductor behaves as a short circuit and capacitor behaves as a open circuit. So in a steady state, this behaves as open circuit. So open circuit means all the voltage that is crossing, that is across this resistor. So when this is open circuit, or all current will flow through this. So voltage across this will be R into I. So we have Vf equal to R into I. So this is our equation. Now let's see the initial condition. At t equal to 0, let's say our capacitor was charged to V0. Okay, you can use, if the initial condition is 0, you can use 0 also. But suppose generally what we do, we take initial conditions for inductor as 0 and capacitor as V0. This is usual tradition. You can do for both. You can get both equation. You can put 0 and find what is this, and you can put V0 and find this. Let's take at t equal to 0, V0 plus is equal to V0. What is the meaning of this? This means V0 is equal to A, t equal to 0, this is 1, and plus Ri. So what you get? You get A is equal to V0 minus Ri. Okay. So now we can put it here. V0 minus Ri, this is equal to this. So let me rub this. So what we can do is, we can take V0 e to the power minus t by tau, and then this is Ri 1 minus e to the power minus t by tau for t greater than 0, because this is a step current response. So the voltage across the capacitor is this. Okay, it is governed by this relation. So this is a step current response for RC circuit, RC in parallel. Okay.